In this video, I'm going to go over finding inverses. We went over this during our live session. So this, if you're watching this, and that means you probably missed our live session when we went over inverses. So our objective here is to be able to demonstrate application of inverse functions by finding the inverse functions using algebraic steps. And then, so that's your content objective. The language objective is to be able to orally explain the steps to finding an inverse. So there's 3 steps. So step 1, step 2, and step 3. So for this first example, we have, so this is the function that they're giving us is written first, f of x equals 3x plus 6. And then in the second column, they want us to find the inverse. So basically in that first column, they gave you a whole bunch of ordered pairs. And remember, in ordered pairs, it's x comma y. So these ordered pairs were gotten by just plugging in the values for x. So they plugged in -5 for x. So that would be 3 times -5 is -15, plus 6 got them the -9. So then that's what they did for all these ordered pairs. To find the inverse, all you do is you switch your x and your y coordinate. So for example, here, -5, -9, instead of having -5, -9, I'm going to have -9, -5. So you're literally just switching your x and your y coordinates. For -6, -4, it's going to be -6, comma, -4. For -3, 3, that one's interesting. Those are the same, so that ordered pair really doesn't change. It's going to stay -3, -3. The next ordered pair, -2, 0, again, flip it, so it's 0, -2. -3, 1, flip it, so it's going to be 3, -1. 0, comma 6, again, you're going to flip your x and your y, so it's 6, comma 0. And then 1, comma 9, again, flip your x and your y, so it's 9, comma 1. And then I'm going to change the display here for just a moment. And I want us to go ahead and graph these. And I know you don't have graph paper, so you're just going to do a sketch. So here's a XY axis. And I'm just going to count by ones. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to give myself a y-axis. I think I have to go a little bit further out on my y and my x. Give me 1 second. Okay, so you'll need to go as far down on your y-axis as -9. So this is just going to be a rough sketch, and that's okay. So I'm going to plot my original in red, and then I'll plot my new in purple. So I'm going to plot each of these points, -5, -9. It's going to be about here. -4, -6. About here. -3, -3. About here. -2, 0, about here. -1, 3, about here. 0, 6. And then 1, 9. So about here. And then I'm just going to connect those dots as best I can. So this is what my original function looks like. So this is my my original function. Now I'm going to also graph the inverse. So I'm going to graph the inverse in purple. So I'm just plotting now all the points in that second column. So -9, -5. -6, -4. -3, 3. 0, -2, 3, -1, 6, 0, and I didn't go far enough, 9, 9, 1. So here's my x. And then 9, 1 would be about here. So we're going to connect the purple dots. And those are my two functions. So the purple line is the inverse of the red line. So what we basically did was we basically reflected the red line over the line y equals x, which I'll show you is right here. So 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2, -2, and so on. So this line right here is the line y equals x. So we basically took and we reflected that red line over the line y equals x. And that gives us our inverse function. So we can do some analysis on this graph here. So the first question here says the original graph is part of what function family? So that red graph, that red line I have, so this line right here that I'm highlighting. So this line, sorry, this isn't exactly perfect line, but it's okay. This line is a straight line, so we call this a linear function. So then they ask, is the graph of that purple line, is that purple line a function? So they tell you that the red line is a function, but is the inverse a function? So to do that, we're going to use what we call the vertical line test. So, and you should be familiar with this from Algebra 1. So in the vertical line test, as long as each vertical line, any vertical line that I draw through that purple function, as long as it touches that purple function exactly once, then it's a function. So here I drew a line and it touches it once, and we're looking at the purple line. So I draw a line through there and it touches the purple line only once. I draw another line, it touches the purple line only once. So we can say yes, it is a function because all the vertical lines only touch in one spot. And then what function family does it belong to? So the inverse of a linear function is always just going to be linear. So it also is just a straight line. So the next example is for you to try. They didn't give you the ordered pairs, so I'll help you get the ordered pairs. So the values for x that I would suggest you plug in are -2, -1, 0, 1, 2, 3, and 4. So what you're going to do is you're just going to plug -2 in for x. So I'll show you it right here. So f of -2. So you're plugging -2 in for x equals -2 over 2 minus 1. So this gets you, whoops, this gets you f of -2 equals -1 minus 1. So f of -2 is -2. So this is my x and this is my y. So x is -2, y is -2. So go ahead and take a minute and fill in the rest of those. When you unpause it, I'll have the rest of that chart filled out for you. So hopefully you took a minute and plugged those in. So your ordered pairs should be -2, -2, -1, -1.5, 0, -1, 1, -0.5, 2, 0, 3, 0.5, and 4, 1. So I want you to find the inverses. So you're going to switch your x's and your y's. When you're done, I want you to graph it. So graph both the original and the new. So you'll need to go out on the x as far as 4, 2, 3, and -4. And then you're going to do the same on the y. So all these are counting by ones. So go ahead, do that one and give it a try. So if you try this, my graphs don't look the best, but you kind of see the idea of this. They're both supposed to be linear lines. So it just has to do with how I spaced everything. Really, this red line would look a lot nicer if it went more like this. Whoops. So if it went more like that, it would be a little bit nicer of a line. So the purple is sort of what the red line should look like, but again, I'm doing without graph paper, so it's a little bit harder. So this would be your inverse and your original on the same graph. And then you could also plot y equals x if you wanted to. So y equals x, so 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. So it looks something like that. So this would be, whoops, this would be the line y equals x. So it's a little messy because we don't have graph paper, but this is an okay sketch. So the next example, find the inverse, and then these next few will be all doing it algebraically, so you won't need to graph. So find the inverse of these. So to find the inverse algebraically, there's 3 steps. Step 1, replace f of x, whoops, replace f of x with y. Step 2, solve, nope. Step 2, switch x and y. And now step 3, solve for x. So those are the 3 steps to finding an inverse. So so this is doing it algebraically. So let me show you those 3 steps in action. So I have f of x equals 2x minus 4. So my first step says replace f of x with y. So instead of writing f of x, I'm going to write y equals 2x minus 4. And just like we did in the table, remember we switched our x and our y's, we're going to do the exact same thing. We're going to switch just the x and the y. So instead of having y equals, I'm going to have x equals 2y minus 4. So all I literally did was just switch my x's and my y's. And then I'm going to solve this for x. Sorry, for y. So so I'm going to draw my line since we're solving. And then the first thing that you want to do is we got to get y by itself. So we're going to undo that subtraction by adding. So I get x plus 4 equals 2y. And then notice now I have 2 times y. So to undo that, I'm going to divide everything by 2. So, I mean, it's okay to leave your answer like this, but you really should simplify this. So first, x divided by 2 doesn't simplify, so we're going to leave that as x divided by 2. But 4 divided by 2, this reduces. 4 divided by 2 is 2. So this gets me x divided by 2 plus 2 equals y. So this is the inverse of that original function. Okay, so here's another example, very similar to what I did here. This example is linear. So I got f of x equals 3x plus 11. So remember, I'm going to scroll up on the left side. So remember, your steps are there. So first replace f of x with y. So y equals 3x plus 11. Switch x and y. So I'm going to switch my x and my y. So I'm going to say x equals 3y plus 11. So all I'm literally doing is just switching my x and my y. And then we're going to solve this for y. So subtract 11. So I get x minus 11 equals 3y. Then divide both sides by 3 to get y by itself. So those 3's cancel. And so I get x minus 11 over 3 equals y. And you could leave your answer like that, but again, it's good to separate them so that we can see our x part and then our constant part. So the first would be x divided by 3. So x divided by 3. And then the second part is the minus 11 over 3. So minus 11 over 3. And that equals y. So I got x over 3 minus 11 over 3 equals y. And there's a couple of questions. You don't have to write them out, but just so we know, the inverse is the inverse of function. Well, even though we have division going on, these wouldn't be whole numbers. It is still a function. It is still linear. So we can say yes, it's still going to be a function and it's still linear. So the inverse of a linear function, guys, is always linear. Okay. The next example, again, you're going to want those steps written out. I want you to try both of these on your own. So I did 2 examples for you. I want you to do these 2 on your own. I'll give you a hint on the one to the right. You're going to need to distribute that 5 before you do anything. So you're going to say this is f of x equals 5x plus 15. And then don't worry about answering the questions at the bottom. So just find the inverses. Both of these are linear. So find the inverses of those. If you need help finding these inverses, please send me a message through Google Classroom, Remind, or email, and I'll be more than happy to help you out.